next question is, in an AP, the sum of the first 10 terms is equals to the sum of the next 5 terms. The first term is A. Show that the common difference of the progression is 1/3 of A. Okay, so it says the sum of the first n terms, that's S10, is equals to the sum of the next 5 terms. Let's just quickly analyze what does this mean. Sum of the first term, we know that they're talking about the sum of the first 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are some 10 terms, first 10 terms, and their sum is going to be S10. But then they're saying that this sum is equals to the sum of the next 5 terms, 1, 2, 3, 4, 5. So this is the 11th term, and this is the 15th term. Now we can't call this S15 because S15 is the sum of the first 15 terms, but these are just the 11th till 15 terms. So can I instead call it S15? S15 would be this entire thing. U1 to U15. So I'm going to call this S15 minus S10. Because if you subtract the sum of the 15 terms, and from that, if you subtract the sum of the first 10 terms, then you're left with the 11, 12, 13, 14, then 15 terms sum. So this is going to be S15 minus S10. So if the sum of the first 10 terms is equals to the sum of the next 5 terms, we can write it as S10 is equals to S15 minus S10. Rearrange, we get 2 times S10 equals S15. Now we're going to use the formula of Sn of an arithmetic progression. That is n over 2. So 10 over 2 times 2a plus d times n minus 1. N is 10. So n minus 1 would be 9. So I'm writing 9d here. And equals to 15 over 2 times 2a plus d n minus 1. So that's going to be 14d. Let's simplify it. 2 and 2 gets cancelled. We have 20a plus 90d equals, I am going to cancel this 2 with this 2, and then that becomes 7. So 15a plus 15 times 7 is 105d. Rearrange, we get 5a is equals to 15d. Rearrange, we get a is equals to 3d, or d is equals to 1/3 a, and that is what we were supposed to show, that the common difference equals to 1/3 of a. Okay. Part B, given that the 10th term is 36 more than the 4th term, find a. The 10th term would be represented by U10. So the 10th term is 36 more than the 4th term. Now let's use the nth term formula of an arithmetic progression. It's a plus d n minus 1. So it's going to be 9d here, equals 36 plus a plus d n minus 1. So 3d. A and A gets cancelled. We get 6d equals 36. We get d is equals to 6. And if d is equals to 6, that means A is equals to 3 times d. So A comes out to be 3 times 6, 18. The answer would be 18 for the first term. Okay. Part B, the sum to infinity of a geometric progression is 9 times the sum of the first 4 terms. Okay, so S infinity is equals to 9 times sum of the first 4 terms. Given that the first term is equals to 12, so A is 12, Find the value of the fifth term. So we'll have to use this formula for the fifth term. A r power n minus 1. A is 12. R n minus 1 would be power 4. So we need the value of r, and then we're going to use this formula 12 times r power 4 to get the fifth term. Okay, back to this formula. Let's substitute the formulas. S infinity is a upon 1 minus r is equals to 9 times S4 would need the Sn formula, which is a 1 minus r n upon 1 minus r. So a times 1 minus r power n upon 1 minus r. Let's simplify by cancelling the denominators, by cancelling the a's as well. So left-hand side is only left with 1 equals 9 times 1 minus r power n. So 1 upon 9 is equals to 1 minus r power n. R power n is equals to 1 minus 1 over 9, which gives 8 upon 9. And sorry, this was 4. So I should have used 4 in place of n. So r power 4 comes out to be 8 upon 9. And we need r power 4 here for finding u5, the fifth term. So the fifth term again is 12 times r power 4. We already know what is r power 4. It is 8 upon 9. Simplify and we get 12 into 8 upon 9. We get 32 over 3. Preferably give your answer as a mixed number. Is there a certain requirement? No. They just said write down the fifth term. So this would be the fifth term. 32 over 3.